Hello, welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Before we start, I'm excited to share that we're hosting Rust Asia Conference 2025 on March 28th in Hong Kong. This is your chance to dive into the world of Rust in Asia and beyond. We've already got Tim McNamara, the author of Rust in Action, as our keynote speaker, and more speakers will be announced soon. We're still open to speaker proposals until December 31st, so get yours in now. Check out all the details at www.rustasiaconf.com. Now back to the episode. Today we have Lars Bergstrom on the show. He's a director of engineering at Google in the Android department. Hi, Lars. How are you?
Hi, Alan. I'm doing great. Thanks for having me on.
It's great to have you on. We've been talking over LinkedIn for a while, and then I think I dropped the ball for a long time, and we finally picked it up. Happy that you could schedule a call with me with the time change. But we were talking a lot before the show. I mean, I don't even know where to even start. Maybe we should start like kind of like what is it you do at Google, so then we can kind of branch from there. Why don't you go ahead and because it's quite long position name, I think.
Sure. Yeah. I've been fortunate to get to work on a whole bunch of different things, including some things that have pulled me in ways I haven't gone in the last 25 years. So the key things for this group, I manage the programming languages and tools that we use to build the actual Android operating system. So that means our C++ compilers, our Rust compiler, the Java environment, and then all of the libraries. So people sometimes, it's probably obvious to your audience from everyone who uses great resources like Cargo and crates.io, but Android, like many other large software projects, is about 75% made of third-party open source libraries. So managing all of those dependencies, making sure that not only are they up to date, but that we reach out and provide fixes or investment where it's needed, or even just make sure that it's working on Android because Android might not be top of mind for many of these library providers. I've worked with those teams for the last 3 years or so. And about a year ago, I also picked up all of the tools and infrastructure we do to update the devices in the Android fleet. So we publicly talk about how we have over 3 billion active devices, over 1,600 different vendors who produce Android devices, and many thousands of variations of models. And we update billions of those devices literally every month with new builds. We have to certify those builds, get them out, make sure that they roll out successfully to a number of different geographies and carriers. And so that's been an interesting adventure for me over the last month. I've been a languages and tools person for the last 3 years. And now I'm, got this great team that's building and maintaining the infrastructure that makes sure that our phones are fresh, that they have the latest updates, the latest APIs, and hopefully the latest new pieces of Rust code as well.
Well, I want to get into the Rust usage within Android for a bit, but just before you say that, something that always bugs me about Android devices, if you don't buy a Pixel or a Google one, you're lucky if you get an update, which because I'm a little bit confused by what you say and what actually I've experienced, right? What I
Mhm.
understand is it seems like the phone manufacturer or maybe even the carrier is blocking those updates from actually happening. So they can downstream or upstream these changes and then they have to actually do the last step.
It gets super complicated because we don't own the full stack, right? We have this interesting ecosystem where we have people who design the actual instruction set architecture. So you have ARM is the big one, but also RISC-V and Intel. Then you have these silicon integration providers or SIPs like Qualcomm and MediaTek and System LSI and Pixel, who actually package all of the components, the modem, the CPU, and everything else. And what they then provide is what we call a board support package. And that's basically what you think of as it's the Linux kernel that you run on and then the drivers that run on it. And then our vendors who sit above it, the Samsungs, the Google, and the rest, take Android and customize it. And the problem is, or what we've run into historically, is that Android can run on some pretty old Linux kernels, but it can't run on a 4 to 6 year old Linux kernel. So if you get a version of the Linux kernel for your chipset that will last for, say, the next 4 years, that might get you 2 updates of Android. And then all of a sudden, you can't update Android anymore because the kernel and the drivers are too old. Now, the great thing that's happened in the last few years is people have realized that's not great, both from a user perspective, because the devices are actually lasting longer. That is the rate of change. Like it used to be when I was younger, right? Every year, the new phones were 20% faster. Now you still see some great improvements, but really, 3 to 6% is fairly common. And so instead of upgrading every 2 years, you might be able to upgrade every 4. Also, from a regulatory perspective, right, we're hearing from many of our vendors, that they don't like all the e-waste that's being produced. They'd like to see our phones lasting longer. And so we have places like the EU where there are really pushes to ensure that there are more years of updates. So Samsung and Google have really led the way on this in terms of providing, committing to 7 years of actual OS upgrades. And we're seeing that come to more of the ecosystem. Now, there are definitely technical challenges here. Again, how do we make sure that we get all of those updates to the kernel and the device drivers so that you can keep getting fresh new versions of the kernel and new versions of Android? Like, given that, it's great that the Android ecosystem has so many different players. You can get phones that have all sorts of wild camera features and all that, but it also means that we don't have just one tech stack that we can say, okay, Lars is just going to update everything soup to nuts, one set of drivers, one set of kernel, with 1,600 vendors in the ecosystem. It's kind of hard to get everybody to march on the same line, but I think many people share your frustration, not just as a user, but also as a developer, right? If I'm writing an application, whether it's in Rust or Java or Kotlin, like, the fact that there's so much fragmentation of just older versions of the operating system makes it really hard as a developer. Okay, so which version? And then maybe one of the vendors has also changed the code a little bit because it's open source, right? They can change some things.
There's a lot of frustrating things, especially being in Hong Kong. I sometimes I deal with like mainland devices that don't have Google Play services, but of course it's still Android or Android compatible, we can say. And it does get a little bit frustrating with some stuff. And sometimes you also get some really goofy screen stuff, like, you can get like a circle phone. I'm sure we probably have some of those. I mean, I remember like the old Moto 360 watch, which was quite nice, but that was a circle one, which you don't see too much anymore. But coming back into Rust, right? Because we're all talking about Rust as Rustacean Station. Do you mind to kind of start to shed some light about how Rust kind of came into the picture? I mean, I can imagine because what I usually see is Rust talked about in terms of security. Is that the start of where Rust was started to be talked about at Google?
Yes. So at Google, it came about because of, security was really the big driver. And it was the Android security team, including some folks based out of Zurich, who really led the charge on looking at how can we replace some of the code. And they had a bunch of observations, right, that are around security defects. So number one, most security defects are in new code. And so what that means is that you don't have to rewrite all of your code to get a lot of the benefits of new security tools and techniques, right? If all you did was make sure that the new code you write doesn't have security vulnerabilities, you would solve a whole lot of your problems. And we've seen this as software developers, right? Most of the bugs, not just software, but most of the bugs are in the new code you wrote. There's exponential decay on defects, whether they're security or just code defects. And so they really focused on how can we, there's a lot of systems that we rewrite over and over again. The Bluetooth stack is a good example. It had already been rewritten multiple times in C++, even before I joined. And so the question was, we're doing these rewrites anyway. Can we use a language that at least eliminates some of the memory safety vulnerabilities? Second, I mentioned earlier all of the third-party libraries that we use. And so some of the listeners for your podcast who've been around for a while may remember things like the stage fright vulnerability, which was a media stack vulnerability in Android. But even on iOS, we have some vulnerabilities. If you remember the silent iMessage that could take over your device a while ago. There's basically these stacks of third-party libraries that are written in C that traditionally had, and on some other operating systems still continue to have, unprivileged access all over the system. And so on Android, what we ended up doing was putting each of these libraries into a process. So we knew like, okay, well, this may be unsafe code, but at the very least, we'll put it in a process, and the worst it can do is blow itself up. That's been fantastic for security. It's really helped decrease not necessarily the number of vulnerabilities directly, but the exploitability of those vulnerabilities. So it keeps our users safe, but at a terrible cost, right? We have to pay process overhead. There's latency associated with this because now you have to do interprocedural call. And so that ends up driving up the cost and making the user experience worse. And so we really wanted to get rid of those. And we see Rust as one of the first real techniques where we can say, okay, there's this code, it's media codecs, it's decoding some, untrusted data. Moving it to Rust, we could actually believe that it's safe enough to start getting rid of some of these process boundaries and see security improvements, but without performance degradations, which is really a new thing that Rust brings to the table. Most of the time when we talk about security mitigations, everyone says, oh my gosh, what's the cost going to be? Is it going to be 3% code overhead because we're adding all of these checks? Is it going to be 2% runtime because we're checking bounds on every integer that's being used to index into an array? And so this Rust has been interesting because it brings performance benefits where most security mitigations really bring a cost associated with them that can often be really hard to swallow, especially in a time where you've got camera wanting to use more memory, you've got all these AI systems that want to use more compute and memory. So there's a lot of tension, a lot of sort of warring tensions at the product level on what are we doing, with the resources available on the phones.
You talked about using Rust for the security reasons, but isn't there other languages that could possibly be used? Because sometimes I hear about, like, say, Zig. I mean, I think Zig is supposed to be known as a much more safer version of C. I don't know if that's really the truth, but that's what I kind of see it as. Was Zig something that you guys have looked at too, or no?
We haven't really looked at Zig kind of at all. It's a little bit newer. And I'll be honest, we invested in, obviously I've been involved in Rust since I was at Mozilla a very long time ago, building out the ecosystem and making sure that it had a stable base. Many times it's less about maybe the language per se, right? There have been many languages that provided safe versions of C, even stuff that we patterned many of the things that ended up in Rust. It's more about this broader ecosystem of, are there contractors you can hire who are going to train your people? Is there a mature and secure package repository that you can use? Is there developer tooling that's available for all of the tools that your developers have? Is it integrated with all of the debuggers? Do stack backtraces work with your crash reporting system? Honestly, when we talk about, I might be jumping ahead a little bit. When we talk about Rust adoption, when I see the blockers, especially at big companies, it's never the type system, right? It's never the language. It's never some feature that's locked behind on safety. The only small asterisk there would be Rust in Linux. We have some Perl script that Bob wrote in 1998 that we use to parse stack dumps when something crashes in prod. And Rust stack backtraces have a slightly different format in the debug symbols than other ones do. And then we have to go and work upstream with LLVM, or we have to, to try and work on compatibility. And so it's really this long tail of how does your language fit into the mature ecosystem. And so when I'm looking at new languages now, because of course, I work on Rust, my team works on Java. We just moved to Java 21 within the Android platform. And we continue to invest in C++ and C++ features because that's certainly not going away before I retire. Rather than looking at other Rust replacements, I'm sort of looking at, if we assume that Rust or some set of tools around the Rust ecosystem help us with the memory safety issues, what are we doing next? So I'm looking at, I work with the Lean Foundation on how do we do formal theorem proving and integrate that so that we can start to talk about, like, okay, now we got rid of all the memory safety bugs. How are we making sure that our code is actually correct, or that it terminates, or that it handles interactions there? So I don't get super involved in, I know there's been some competition with D, with Zig. Well, D was longer ago, more recently with Zig. It all sounds like they're doing fantastic work, but I don't really spend a ton of time digging in on any of those too much.
Okay, yeah, because I was just kind of curious about it. Was there a period where you're saying, okay, let's try Rust, let's try X, let's try Y, and let's see which one fits most? But it's interesting that you bring about all these other extra things, and I think that makes a lot of sense because sometimes it is down to like semantics or whatever you want to call it. It's like some trivial thing, like that, how you write. But then, like you said, how can you put that into your workflow? Is that which is the least friction? So it sounds like, at least according to your side, you're saying it's actually easier for the most part to put Rust into your current build chain than something else. Is that what I get?
Yeah, and it's really hard. I think we at Google, this is before I joined Google, now almost 4 years ago, had been looking into Swift as well. Because one of the great things that Swift has is much better fine-grained interoperability with C++. And so that was super attractive. But again, some of this is all at a matter of time. Like if you made the choice in 2024, Swift is much more attractive than it was, say, in 2020, when it didn't support other platforms. It was very hard to land fixes upstream because it was not, at least for Google, and so we did. I know there were a bunch of people at Google who evaluated it and were very promising, and were very hopeful about it. But again, it was not Swift the language. It was Swift the broader ecosystem. Could it support all our platforms, all our tools for fleet-wide profiling and all the rest? And often the problem is if you can't support that full set of tools that are really required to operate in these big commercial environments, it's like the checkboxes on the side of the label where it's like, do you support these 25 things? Nope, 24 of them. Sorry, can't use your product. And so, often that can end up preventing adoption more than other things.
What was the first piece of Android that was rewritten in Rust, and how did it go? Was it easy? Was there a lot of bumps in the road? How was that?
This is before my time, but I can talk about both at Mozilla and at Google, where the biggest mistake is committing too early in a very, very big way. So at both Mozilla and at Google, we did smaller things, right? Look at one small library, one small piece of code, and then figure out, does it actually integrate with our build system? Cargo very famously does not play well with others. And so, how are we going to build our Rust code? How are we going to bring in packages? Where are we going to store them in the build? So, how are we going to update them? How are we going to make sure that it meets our SBOM requirements? So, I don't remember the specific one. I think it was one of the small C library that was just an external dependency with a C API that had a really good Rust alternative. And I apologize, I'll try to look it up afterwards. And at Mozilla, it was MP3 parser, although we'd also been rewriting the URL parser and a few other things. And you sort of, you go forward with a few of these small things that are not in critical areas. And that's really what I would tell other people who are looking at adopting Rust. Like, don't make your first product choice the thing that you're betting the business on. You're just, I always joke that probabilities are multiplicative, right? You're adding the risk of adding a new language on top of your riskiest feature that your company's trying to ship. Like, absolutely not. Like, you don't want to get in the way of the freight train that has to leave before the Christmas holiday shopping season. You want to be over there looking at your YUV decoder and saying like, hey, could we kind of kick the tires with that and see if we can do color conversion in Rust, and then have something that sort of integrates in a safe way there. And only some of those will work out, right? You'll be working in some domains because especially when I was first working with Rust, or even Android was first working with Rust, the Crate ecosystem was not as mature as it is today. So you would go down a route and then you would say like, oh, wait a minute, the Rust HTTP stacks don't have some of the new HTTP 3 features that we really require. So this particular experiment isn't quite going to work. Oh, but we do have some really good crates for doing serialization and deserialization. So we won't get in the way there, because like just kind of doing that drill down to understand, is the stack and are all of the things in the ecosystem mature enough to replace some of these things? Because a lot of the C code you're replacing, right? It's 15, 20 years of people hacking on parsing formats or codecs or doing network communications or things like that. And there's just really a lot of edge cases, right? I think it was Jamie Zawinski, when Mozilla was doing the Firefox rewrite, famously called out sort of like how much work it was to rewrite a web browser, just because the amount of work that went into just the FTP protocol, which of course is deprecated at this point. And he was right? It ended up taking a decade to really re-implement the whole web browser and all of those corner cases and features. And really that's what I warn people about, is just until you're pretty sure you've got your full dependency stack, you don't want to commit, because otherwise you could find out like, oh my gosh, I have to go and, we got to get 20 people on building out some part of the network communications stack, or we can't ship this in time for the Christmas holiday season.
It's good to start small. The only thing I could say about starting small is you may not have enough impact to really get data on, was this worth it, right? That, if it does something very small, then how do you know that you have a benefit? So that's kind of like my next question is, how do you know that you're going in the right direction? You write something very small, maybe it's a simple sum function or something like that. At what point do you say, actually, this makes sense, this is better? What's that like?
There's often a chicken and egg, especially right now in sort of the corporate world, where it was very different in 2021, right? People were throwing headcount. We had zero interest rate phenomenon going on. It was very easy to get projects greenlit, and people say like, "Oh yeah, sure, let's rewrite the whole world in Rust. Let's see how that goes." Today, like you said, there's this very high proof of burden, especially at the exec level. So I would say, I kind of think of it in three phases, right? The first one is what we were just talking about, getting some people, probably volunteers. It's probably barely funded or supported, just proving viability. Like, you really want to have that proof that this could work. Dave Herman, who used to work at Mozilla Research and well with us, his quote that he used all the time was, "Nothing succeeds like success." So first thing is like, don't worry about the metrics as much. Just prove that you can get a working system that builds and runs and shows all of that. And then try to find your first partner who's ready to make a bet. So the first person like me or some other, It's not the CEO having to approve a big investment plan in Rust, but someone who's willing to say, okay, I'm willing to take, 4 or 5 people offline to try and rebuild the system in Rust. And that's really the proof point that you're looking for, because you want that person who's going to be an executive advocate for Rust in the rooms that you don't get to be in. So the thing that, most of the listeners can do who are on the ground is make sure that project's successful, right? Your job doesn't end when selling and like, oh, okay, great. Team A is now going to go off and rewrite this thing in Rust. I think one of the things that the Rust and Android security team has done is really work integrated with teams. When teams are first starting with Rust, they come in and they help with the tricky code reviews, architecture reviews, crate selection, all the stuff that I think people who've been in working with Rust for many years would be able to do sort of by default. They sort of know where the dark corners are and how to stay on a good, well-lit path, but really just trying to make sure that that first team is successful so that you have not only this larger group of people who can write Rust code, hopefully more independently, but also so that you have some executive sponsor internally who's going to go when other teams are proposing doing Rust. They're going to be able to say like, oh yeah, we did Rust, no big deal, we rolled it out. Couple of bumps, we had to do some training. There's this great firm, we recommend you use them if you do it. And then from there, you can get to where we are in Android, but which has taken many years, where we now have a default. It's not a mandate, but it's basically if you're bringing new native code into Android, you have to prefer a memory safe language. And Rust is on that very, very short list. Or you have to come to me and a couple of my peers to get an exception for why you still need to use C++. And there's always valid reasons, right? There's some library that's out there. There's some really, really strong ecosystem. Maybe there's some regulatory requirement from some particular industry that you use this exact library. But those reasons are becoming vanishing few. But you can't jump all the way to the end, right? It's a journey and it could take many years. And it can be frustrating, right? These companies often move more slowly than people would like them to. But really, if you rush it and you fail, the other problem I've seen is that companies who have had failed Rust adoptions, and I've talked with many of them, it leaves scars. Executives have very long memories. And, the only thing they may remember is that failed Rust project that caused them to miss the Christmas holiday launch window one year. And they'll be darned if they're going to make that bet again. Right. And so now you really have to be careful when you're doing these things, because like you said, it's hard to get that positive signal, but it's very easy to get a sticky negative signal. So experiment in ways where failure is cheap, where if you can't do the parser, it's fine. We all move on, no big deal. But again, coming back to my earlier analogy, you don't want to chain it to some critical launch, not just for Rust, but for any really experimental initiative that you're doing. You're changing the process for managing tasks or your CI/CD system or your testing system. If you're taking a bit of risk there, even if it's just risk relative to the company, not relative to the industry, just got to be very careful about how you're doing that, because you can end up poisoning the well for those sorts of changes for, well, basically until those executives retire.
That's a pretty good point. You got Rust in, you started rewriting small. At some point, you started adding more and more. You see the gains. I mean, where are we at with native code and in Android? Because I'm sure it's probably bumped up quite a bit. Like you said, guys can rewrite. You have the resources and maybe even the need to sometimes actually rewrite this stuff. Are we at a more than 20% by now, or that's way too high? I think it's fixed way too high.
So again, our goal is really focused on of new code that comes in. So for the first time this year, this Android release, we've released more native code is in Rust than in C++, which is a huge deal when you consider how much C++ code just comes from third-party libraries. And I think we're right at or just over 3 million lines of Rust code in the Android code base. So that's, 3x growth over the last 2 years. It will still be incremental, and we don't have some target like 50% of the overall native code is in Rust. We really are just focused on of new code that we write. Can we get it there? Now, I know there are some folks like DARPA, the Defense Advanced Research Projects Agency at the US, is really looking at this new program called Tractor that would enable you to move all of your C code to Rust so that you can accelerate some of these migrations. And we've worked with the Immunon people who work on C to Rust. But, from my point of view, I think those tools are fantastic, and I'm glad people are investing in them, but they're not the big thing for coming back to the security needle. Like for fixing these security specific issues, just making sure that all of our new code is in Rust is really sufficient. Now, in the long run, are there other benefits to Rust? Some of the stuff I talked about in my Rust Nation UK, like we find that teams are way more productive when they're using Rust on pretty much every metric compared to C++, whether it's, how long do reviews take? Does your code get backed out? How fast can you land CLs and land new features in the code base? And so there may be other reasons, even beyond security, to move to Rust for your team. But our flagpole on the Android side is really, really pushing on security.
Speaking of the being as productive part, I'm kind of curious, how can you measure Rust versus Go? Because to me, they're quite different, right? With Go, you're probably building services. With Rust, you're really doing, I mean, especially with Android, I mean, you're doing core things. It's totally different type of programming. So how can you compare? To me, it's like apples and I don't know, broccoli. Both is delicious, both has nutrients, but they're different, right? In the end.
At a high level, because I own the portfolio of languages across Android, usually when I talk about it, I want people working in memory safe languages. So if that means Go or Java or Kotlin or Dart or Prolog, like I really don't lose any sleep as long as these are memory safe languages, and really prefer those. If your application or server's performance characteristics allow you to use a garbage collected language, absolutely go for that. That's going to be way easier. That's going to be much more productive for your developers in terms of metrics. It's just if you need native code performance, then I ask people to prefer Rust. Now, where we see people move from Go, not just inside Google, but historically outside, has been where they couldn't afford a garbage collector or where they really needed tight control over memory and they were moving to a systems language. And to get that level of performance or control, they weren't able to do it in a productive manner in one of the other languages. And I really don't want to attack Go here. I don't want to attack Java or Kotlin. These are all fantastic languages, most of which I invest a significant amount of money in as well, from making sure it's updated and available. But it's really when you need to get that high level of control, you really need to get on top of your compute resource usage or your memory usage or your latency spikes, then helping people not have to go all the way to C++ or try to do horrific contortions in their Java, Kotlin, or Go, but instead be able to use Rust as an alternative. That's where we see people manage to get that productivity. But I would hope those are the rarer cases. The more that we can have people working in high level languages, including garbage collected languages, the better. I don't have any plans of world domination of everyone writing everything in Rust. That's as a programming languages researcher, that would make me sort of die a little on the inside. I think the richness of our ecosystem is having languages that allow us to be productive, that allow us to express the main concepts easily in our code and then bring it to production and iterate on it quickly. And saying that there's just one language for doing that is that would be sad from my point of view.
Is there any plans to let Rust be like an app language? Because right now it's, yeah, you can include it probably with like NDK, things like that, but you cannot fully write a whole Android app with Rust at this point, right?
Again, we don't want to replace Kotlin. We think Kotlin and Compose or Dart and Flutter are great ways to build either native Android APIs for Kotlin or cross-platform APIs for, Dart and Flutter, which can take you to iOS as well as the web. Where we really see Rust and where we've seen continued increased adoption of Rust across Android apps, because of course I check it out, right? I work at Google. I check the Play Store. I'm like, hey, I know how to check if binaries have Rust code in them. Like, do they have the Rust outlock symbol? Did they generate LLVM code that looks certainly Rusty? And we see just the adoption of Rust within Android apps absolutely taking off. But it's basically people doing kind of what we did early on Android and saying like, oh my gosh, I had this dependency on something to parse certificates or to do video transcoding or change image formats. Let's move from that really old janky C library that has a whole bunch of vulnerabilities to some newer library written in Rust that's memory safe that we can jam on in. And then at that point, okay, it's just sitting across a C API. It's not worried about some of the complexities we talked about earlier on Android of how do you write native code that can work on every different version of Android that can interact with the operating system features. I mean, we are trying to make that easier. We're trying to, work with the community to improve some of the interoperability, but we don't, I'm sure there will be people who do it or have already done it. Writing whole Android applications in Rust, again, is really not the goal. It's taking those critical pieces that you were, sending off to C or C++ today and making sure that those can be replaced with Rust. That's really where I want to make sure we focus for app developers. But I have no desire to grow up the stack into, there are a number of great multi-platform solutions, including React Native, that allow you to handle either your business logic or your UI level. It's really just the low level operations that are super performance critical, where I think Rust has a good spot on Android.
That's a good point. Yeah, because I have been trying to play around with, writing business logic within Rust and then exporting a C compatible library, but I've actually had some issues with trying to add that to the build chain. It's always kind of complicated. Like I have to kind of fiddle with the pod spec for Cocoa Pods, and this stuff. I find it to be quite difficult. Maybe I can ask a personal question because I'm just kind of curious. Like, if I wanted to do this kind of stuff in Android, is there a particular like Gradle plugin that you recommend to do?
I can get back and have some names for the listeners. I know people struggle on the iOS side, and this is actually the biggest blocker that we hear from app developers for Rust adoption in Android is the fact that Apple doesn't have Xcode support for being able to embed their Rust code into their the iOS side of their application, where they have some shared library. They can embed it if it's in C++, no problem, but there's no Rust C in Xcode, and the build rules, like you mentioned, really don't work. On the Android side, there's Gradle rules as well as Bazel plugins that work fairly well from what we've seen in terms of uptake. We do see more people, the folks who are adding Rust to their Android apps tend to also have replaced the whole build system because they're part of some larger organization. So we see more people using Bazel than other build systems. But there is some Gradle support for it. But I would have to, specific Gradle plugins, I would have to go back and check on. But we see people using it, and we see increased even within, our developer tools. We see people shelling out to call and compile Rust code more often. But really, it's if I had one ask, the biggest thing that would advance usage of Rust within Android applications is Apple shipping a Rust compiler for iOS devs to be able to easily ship Rust code, because that's the biggest one I run into with other partners.
You mean you want them to, like, if you do like the build install, like the, I don't know what you call that, build essential or whatever, to actually include the Rust compiler within there?
Yeah, yeah, because people, they want to use the Apple tools to compile. They're also very worried about shipping a binary into Apple's store without using the Xcode provided tools. And so they don't want to grab like a different Rust compiler and a different set of Rust build rules. They don't know if their app's going to be approved or not if they haven't used just the compilers that were provided in Xcode. And I can't speak for Apple, so I can't give them business advice on this. I'm like, I don't know. I mean, I've seen people do it, but I don't know if that's against policies or not. And I'm not their lawyer or Apple's lawyer. So, having Rust as a supported language from Apple would really help for people who are trying to build applications that use Rust.
You seem like somebody who may know this kind of question, but I often hear people kind of talking about LLVM versus GCC and which one's better or not so good or whatever. Do you mind to kind of shed some light on this? Because what I sometimes hear from some people is that GCC is really, really good. LLVM, it's okay, not as good. I wish that Rust could actually run with GCC. I know there's a project working with GCC with Rust. I'm not sure the current status, but can you give some insight about why people should really care which one and why do we have two different ones? As an app developer, I don't really notice a difference as long as it compiles and it works, but I'm sure there's a difference for specific use cases.
Dragging me into the pettiest of flame wars. I love it.
Well, I didn't talk about
but
tabs versus
no,
spaces.
I
That's
think
even more petty in my opinion, but
no, I think so. So GCC has been around forever. LLVM is relatively newer, at least for an old guy like me. I think at a high level, number one, having both of them makes them both better. Right, there is a constant. GCC is implementing this optimization that LLVM doesn't have. LLVM implemented this optimization that GCC doesn't have. In the same way that Android and iOS make each other better by existing and showing what more is possible, I think having both of these compiler sets and having them both be viable is really critical to having a robust and evolving ecosystem, because otherwise people will go, "Oh, okay, well, we got one compiler library, let's just go." Now, historically, GCC has supported more platforms, more targets, and has also had more industrial and vendor support. So if you're building some piece of embedded hardware and you need a custom compiler tool chain or custom targeting, there's a bunch of folks who can provide you a GCC based solution that works for those platforms that may not have great target support from LLVM, because LLVM sort of grew up in the modern era. It does have great embedded support for many targets, but a lot of this just long tail of hardware. And so folks often, especially in the embedded space, GCC will be their first experience because that was what was available or was packaged with the board or was provided by the board's vendor. Now, when we talk about specific trade-offs, I can't tell you today which one is. If we had identically good Rust front ends and then we were generating code from GCC and LLVM, a bunch of folks on my team, I mean, obviously Android is very famously LLVM only, but many of the folks on my team are both GCC and LLVM contributors. And so, I could go into that. I could go to them and say, like, which optimizations does GCC have today that LLVM doesn't? They would have some small list of cases where GCC might, turn something from a for loop into a vector that uses single instruction, multiple data operations a little bit better. But for the most part, it's six of one, half dozen of the other. They're both absolutely fantastic tool chains. The thing you don't want to do though is mix and match, right? You really don't want to have libraries that were compiled with one versus the other and then try to link them all together and expect things to work well. They have different ways of handling sort of global variables, static initialization, dynamic loading of libraries, as well as some of the security properties. So address space, layout randomization, pack and BTI, and other security features. Like when you try to mix and match the two of them, you're going to have a bad time. So you kind of got to go all one or all the other within the stack, because mixing and matching them, it's gonna completely blow up on you, even before you talk about accidentally having multiple versions of libc++ pulled in or anything like that. But LLVM was really designed to be a reusable compiler framework, and a lot of the reason that it took off is that GCC was explicitly not designed to be that. It was meant to be a full compiler pipeline, and this resulted in sort of a lot of flame wars of like, well, we just want to be able to reuse the back end, or we just want to be able to reuse, we want to have a different intermediate representation or target. And you can see that with, if you look at the ML and AI space, right, most of the innovation there is happening in LLVM, mainly because there are things like MLIR, right? You want to define a different layer of the compiler that can be targeted by these ML compilers that isn't C-like, but is more amenable to tensor computations or matrix computations. Oh, well, LLVM supports that sort of both architecturally and philosophically. And so that's why you see a lot of that kind of work moving to LLVM and maybe not showing up over on the GCC side, because LLVM is more open to those kinds of contributions, whereas GCC has been more of a sort of classic compiler pipeline. That's changed over years, especially over the last 5 to 7 years. They've become more open to other mechanisms, but really LLVM is just sort of tailor-made for that kind of experimentation and optimization, because it came out of academics, right? It was very well supported by Apple after Chris Latner went there, but it was a UI/UC project out of Urbana-Champaign, from long ago, that sort of grew up from this academic background of experimentation for building compilers and tools.
Okay, that makes a lot more sense. I didn't know that you can't really mix and match them. It's interesting to hear that. So basically, when you're building Android, you said you're LLVM only, so you need sources of everything that's not close compiled, and you need to just compile everything from scratch or compile the dependency once and then just include it, right?
From a software supply chain security perspective, when you're building something like an operating system, whether it's Windows or Android, you really want to have the sources to everything, right? You do not want to trust some binary that some third party produced, not even as a tool, right? Much less as a compiled artifact that you would send out. So you really want to have the sources and build all of it yourself, both for assurances, right? You want to be able to audit all of the code to ensure that no nasty person has come in and done something terrible, but also from a fix perspective, right? If we find out that there's a bug in some line of code and it's being exploited right now in the field, we need to be able to turn around a fix in ideally minutes, if not hours. And if we have to go to some third party and say like, hey, vendor B, whenever you wake up in the next morning, could you respin with a fix for this critical security vulnerability, right? We have billions of devices in the fleet. We need to be able to turn around that fix super fast, and we really can't do that if we're pulling in pre-compiled binaries. So we would have to compile everything ourselves anyway, but using one compiler stack allows us to make sure that all of the features, including profile guided optimization and the other things we do to try and optimize the layout of the code or to inline across modules, again, that requires that you use only one compiler stack. You're not going to be able to do that sort of cross-module inlining if you have mixed compilers.
Oh, that's pretty interesting. So then, if you actually do find a bug in somebody else's code that's, say, like outside of your stuff, do you actually upstream that back to them? I'm guessing you probably do, right?
Oh, yeah, yeah. We are very active contributors to all of our upstream, whether it's a security fix or even bugs and performance fixes. Like the only reason that we will carry a patch is because upstream would not accept it. So we don't see any value on the Google Android side and being like, oh my gosh, we have the best version of SQLite. Like, absolutely not. We have a fantastic relationship with the SQLite team. They do great work. If we find bugs, including performance bugs, we try to bring those back to them so that they can improve the quality of the product. For them and many others, we also provide financial support. We really try to recognize the fact that we rely on so much open source code, and we want this to be as good of a relationship as it can be. It's always hard when you're a small team. SQLite team is relatively large, but many of the libraries we use are maybe just a couple of developers. And it can be super overwhelming, right? Like, oh my gosh, Android found a bug. There are now 47 people pinging me and letting me know that there's this bug and asking me to participate in this CVE, and I'm not supposed to tell anyone about it, and all of that. And we recognize that can be super overwhelming. It's like the entire family showing up by surprise at Thanksgiving. So we do try to do what we can to mitigate the overwhelming impacts of that by trying to find ways to support the various open source libraries or their foundations or their developers directly wherever that makes sense.
We're approaching the end of the time. I mean, we can go so many topics because you have such a long history with Rust and programming and stuff like that. I guess I could leave, you with any kind of last words that you want to give about, your use of Rust or some guidance, etc. You've given some already.
I think the biggest thing when we talk about, because you want to hear about Rust at Google and Rust adoption, I think the biggest thing is remembering that it only starts with the pitch. Telling people why Rust is great or having the presentation or showing them materials is sort of the beginning of the journey. If you really want to see Rust adoption within your company, it's a commitment of your time to make sure that they fully land it, right? You're with them when they are having their first troubles with unsafe code blocks or pulling in new crate dependency or some tools internally. You really can't just sort of come around and sprinkle Rust interest in your company if you really want it to be successful. But if you do, if you go on that journey with them, it's a great way to not only advance Rust adoption, but also I've seen people get really good visibility, within their companies and end up getting really great career outcomes because they're seen as this person who not only, delivers advice, but also helps really improve the quality of the products that are going out. And at the end of the day, that's what the business cares about. The business doesn't care whether things are implemented in Rust. They care about, did we implement something that had fewer security vulnerabilities, that got to market faster, that was more productive for our teams. And so just sticking with that and helping them through the whole journey is really the biggest place where I see Rust adoption fall over, and where I think your listeners have an opportunity to really help companies in their journey.
All right, that's some good words of wisdom. Again, thanks for coming on. It's nice to finally meet you, and hopefully have you back on again in the future.
Yeah, sounds great. Thanks. And good luck with all of your future episodes. I'll be listening.